Hello friends, welcome to VK Lectures. In this video, we will be discussing the question number 42 from Karnataka Kset 2024. How many flip-flops are required to construct mode 1024 ripple counter? So mode 1024 ripple counter. This means that it can count number from 0 to 1023. This many states are there, this many unique states. Okay. Now how many bits are required? So number of bits it is given by log to the base 2 of n. So this is the value of n, or how many states? 1024. N equal to 1024 from 0 to 1023. So number of bits is equal to log to the base 2 of n. So that's equal to log 2 of 1024. So this value is nothing but 10. So log 2 of 1024 is 10. So 10 bits are required, or 10 flip-flops are required. To construct mode 1024 ripple counter. Here are some key points regarding the ripple counter. So ripple counter is a type of asynchronous counter. There are also synchronous counter apart from the asynchronous one, and asynchronous counters are made up of flip-flop which is connected in series. Now the operation of an asynchronous counter, that is the only first flip-flops. The first flip-flop is driven by external clock, while others are triggered by preceding flip-flops output. So for example, if you have two flip-flop here, the first one is triggered by externally and the second one is triggered by the output. Here is the output. The output of the first one will be the input of the second. So only the first one will be triggered externally. The other flip-flop will be going like this. So the third one, the output of the second one will be the input of the third one. Similarly, it goes on. Now for binary counting, it counts binary sequence like this: 0 0 0 0 0 1 0 1 0, and it goes on. Now compared to the synchronous counter, the design of the asynchronous counter is, or the ripple counter is better, which requires fewer connections. Now the speed is slower because it has cumulative delays, not suitable for very high frequency application. It is suitable only for low frequency applications. Now coming to what is flip-flop, it is just like a basic building block of a sequential circuit. Now a flip-flop is a bistable device. Bistable device in the sense it has got two stable states, 0 or 1, and this 0 or 1 is nothing but which is stored in one bit of the data. That means for any flip-flop, it will store one bit of data, and that bit can be either 0 or 1. Now for flip-flop, it is controlled by the clock, and the state changes only when there is change in the clock signal, clock pulse changes, only then the uh, the state will change. Examples are used in counters, registers, memory unit, microprocessor. Example, microprocessor. These are the examples where it is being applied. That means flip-flops are used in counters, counting, registering, memory units, and microprocessor. And flip-flops are made using logic gates. Example, NAND or NOR. uh, there are different types of flip-flops. Generally for SR flip-flop, set and reset flip-flop, JK flip-flop, this is just the modified version of SR flip-flop. Now data flip-flop is there, along with that toggle flip-flop, T flip-flop or D flip-flop in the case of data. Now what does it actually does? The flip-flop, it stores one bit of memory, and that bit of memory can be changed using a clock control. A pulse from a clock control will move to the flip-flop, and then the memory will change, or memory will revert back to 1 or 0. Now here is another question for practice. How many flip-flops are used or required to construct a mode 512 512 ripple counter? Options are here. You can comment your answer in the comment box.